All right, so we're looking at 3.5, pooling it together task. And it starts off by saying, Allie and Dane work at a water park and have to drain the water at the end of each month for the ride they supervise. Each uses a pump to remove the water from the small pool at the bottom of their ride. The graph below represents the amount of water in Allie's pool, A of x. So when I talk about A of x, I'm talking about Allie's pool, and Dane's pool, D of x. So Dane's pool is D of x over time. In this scenario, they started to work together to drain their pools and create the equation. So if they're working together, that's going to be G of x, and that's equal to how they drain their pools separately. Okay, so what does G of x represent? So G of x represents is this total amount of water in both pools. Is the total amount of water in both pools over time. Okay, so it says create a graph of G of x on a new set of axes using the graphs of A of x and D of x. Okay, identify G of x and label scales and axes. Okay, so what we need to do is add these two equations together. So if this is 4,000, 8,000, it's going to be 12, 16, 20, 24, 28. So Allie's pool, I guess I probably should have made this one blue. It's too late. I'll go this way. So Allie's pool has 28,000 gallons, and Dane's pool has 24,000. So if I add those together, that's how much it starts with when they are draining both pools. So 28,000 plus 24,000 is 52,000. So I've created a graph down here. 52,000 represents how much water is in both pools combined. Okay. All right. And then if we look down here, 5, 6, 7, 8, 9, 10. At 10, we have they have the same amount of water, and that amount of water looks like it's about 14,000. Okay, so if they both have 14,000, together at 10 minutes, they must have 28,000. So at 10 minutes, 28,000. So now that I have 2 points, I can connect my line. Make sure the line's connected. And we have G of x. What it should look like for both pools together. Okay. So let's go ahead and write the equation, because it says write the equation for the function of G of x using the graph you created. Okay, so G of x is equal to, let's find our slope, let's do a slope triangle. If I use this point and this point, I would have 52,000. Okay. And I would have the point 10, 28,000. Okay, so using the slope equation, or to find the slope, I do y2 minus y1. I'll just write this equation here. y2 minus y1 divided by x2 minus x1. Okay, so let's do that math. 52,000 minus 28,000 over 0 minus 10, which equals 24,000, and 0 minus 10 is a negative 10. Cancels out, so my slope would be a minus 2400 x, and my start value is 52,000. Okay, so the point where I start is 52,000. Okay, so we have our equation for g of x. Then it says, compare this equation to the algebraic representation of finding the sum of the equations for a of x and d of x. Okay, so this is something that we found in the 3.4 task. So I'm actually going to bring it up here. Okay, so if we're adding, we're basically going to say a of x plus d of x. So right here, if I want to add that together, that equals g of x. So g of x equals minus 1,000 x plus 2,400 or 24,000 minus 1,400 x plus 28,000. So if I combine my like terms, things that are in common, I have 28,000 plus 28,000 and plus 24,000. Make sure you include the sign. So, and I also have minus 1,000x and minus 1,400x. So g of x equals, if I combine my x's, I would have minus 2,400 or 2,400x plus 24,000 plus 28,000 is 52,000. And as you can see, it is the same as the equation we got from the graph. Okay. Should the algebraic equation g of x be the same as the graph? Yes, it should, because we're adding the same starting amount of water and taking water out at the same rate. And then problem 5 says, use both graphical as well as the algebraic representations to describe characteristics of g of x and explain what each characteristic means, each intercept, domain, and range for this situation, and for the equation, the maxima and minima, whether or not g of x is a function. Okay? So, g of x decreases at a rate of 2,400 gallons per minute. Okay. The start value was 52,000 gallons, which means the y-intercept was 0, 52,000. The range So when we talk about the range, we're talking about the lowest value to the highest value. So the lowest was 0 up to 52,000. So the range was 0 to 52,000. And those are both possible values. The domain looks like it drains at about 22 minutes. So I would say from 0 minutes to 22 minutes. And we could actually plug in to solve to make sure it's 22 minutes. I didn't actually do that. The maximum would be 52,000 gallons at 0 minutes, and the minimum would be 0 gallons at about 22 minutes. It says, explain why adding the two values of the y-intercepts together in ax and d of x can be used to find the y-intercept in g of x. A of x and d of x represents the starting value. So in this equation, if Dane starts with 24,000 and Allie starts with 28,000, then together they have to start with those combined 52,000. And for problem number 7, it says, can a similar method be used to find the x-intercepts? In this method, we added the two start values together, but can you say that because it took, let's see, I think it's about 20 minutes and 24 minutes together, should it take 44 minutes? No, you can't add them together. What happens is the time should be somewhere in between the two, not way over to the right.